This video is on the simultaneous equations, the algebraic method, elimination. So the algebraic method consists of two methods. This is just the first method called elimination, and we've done two videos. So this is the second of those two videos. Just to recap what we did in the last video, we looked at the process of using elimination, which is where you're going to eliminate, hence the name, eliminate one of the variables in your equation. And the way you eliminate those variables is you will either add or you'll subtract your equations. And to decide whether to subtract or add, we use this little acronym, I guess. I use, if it's same, we subtract. If it's different, we add. So same, subtract, different, add. And what I mean by that is you will need to look at the coefficients. And here I've highlighted the terms that have either exactly the same coefficient, like these two, or the coefficients are equal in magnitude but opposite in sign. That just means they've got the opposite sign but the number part is the same. So once you get equations that look like that, well, if you either add or subtract them, then you will eliminate a variable. So for example, if you look at these two terms, these count as different because they're opposite in sign. So if they're different, that's where we add. So what I would do in this first example is I would add equations 1 and 2 together. And when you add the green terms, that's y plus minus y, I hope you can see that we get 0, which means that the y terms would be eliminated, and then I can go and add the x's and the constant terms and find x. So if I look over here, I've got two terms that are the same we subtract. So I would take equation 1 and equation 2, and I would do 1 minus 2. And when I do that, let's just concentrate on the green terms. I'm going to do minus 3y, minus, and then I minus the other term because I am subtracting the terms. My other term is minus 3y. So just pay attention to the fact that you will get a double negative here because we're minusing a negative term. And once again, well, two negatives together will make a positive, and minus 3y plus 3y is 0. So once again, by subtracting these equations, we will eliminate the y's, and we can then work out what x is. So that's the most basic form of elimination. But then that begs the question of, what do you do if the coefficients are not the same? Okay, so we're not always going to have the same coefficients. In that case, what you're going to do is you're going to take your equations, but you're going to have to create another equation. Maybe you'll create one. You might even have to create two equations. And the way you're going to create those equations is you're going to multiply every term, not just some, but each term in an equation, in one of the equations, or sometimes both, to change the coefficients. So for example, if I look over here, I can make both the x terms 12, or I could make both the y terms 6 or minus 6, 1 6 and 1 minus 6. And then I can add or subtract. And over here, I've got 4 and 17. I could make those into 68, but that's not as nice, I guess, as making the 6 and the 5 both into 30. So let's practice what we're about to do on the next slides. Here, I think I might actually change the x's to the same term. So I'm going to make the x's 12, and I'm going to do that by taking equation 1 and timesing it by 4. And I'm going to take equation 2 and then multiply that by 3. And when I say multiply, I do mean every single term. So you've got to be really particular that you do this term, and this term, and this term, this term, and this term, and this term. So let's give it a go. So equation 1 times by 4, well, if I times 3x by 4, I'll get 12x. Then I'll move to the next term. If I multiply that by 4, I get minus 8y. And the last term, if I times 11 by 4, I will get 44. Let's do the same to the bottom. The second equation I'm timesing by 3. So let's go for it. We've got 4x times 3. That gives me 12x. And the 3y times 3. That gives me 9y. And then 43 times by 3. Well, 40 times 3, that's 120. And 3 3s are 9. So I should be getting 129. Now, what I want you to notice, well, sorry, before we try and work with these equations, when you create new equations, you have to number them. So this becomes equation 3, and this equation will become number 4. And these other two equations, they're not really, well, actually, I'll take that back. So now we've got equations 3 and 4. What I want to concentrate on is the fact that I now have two terms with the same coefficient, just like these equations on the previous slide. So that's my goal. My goal is to get a set of terms with the same pronumeral that have the same coefficient, or the coefficients are opposite in sign. And once I've got that, let's go back to our little acronym, same, subtract, different, add. Well, these are exactly the same. So what I will do then is I will subtract 3 minus 4. Okay. Over here I've got, I'm going to actually change both the y terms to 30 in this second example. So I'm going to call this equation 1, equation 2. And to get them to 30, I'm going to take equation 1 and times by 5, and I'll take equation 2 and times by 6. And so when I do that, I'm going to get 20x plus 30y equals 55 by timesing by 5. And then equation 2, I have to times by 6. So if you need your calculator for this one, you can use it. 17 times by 6 gives me 102x. And minus 5y times by 6, well, since it's negative, it's going to give me minus 30y, and the number 1 times by 6 is 6. So once again, I'm going to number my new equations because I've created new equations. Every new equation gets a new number. And then I can see that I've got two terms that are, well, they're going to actually count as different. They're going to fall under the different category, but they have the same number, or the integer. Well, it's not the integer, it's just the magnitude, I guess you could call it, is the same, but they count as different. So because they're different, what I will do is this time I will add them. Okay, and when I add 30y plus minus 30y, these terms will cancel. They will be eliminated. All right, let's do a question straight through all the way to conclusion. So I've got two equations that I will begin this question by numbering them. Oh, this is the question from before, isn't it? Let's write down those two equations. Sorry, that's this example over here. So what I'm going to do is I'm just going to take the two equations and write them down. So we've got 20x, because we've done all the hard work, plus 30y equals 55, and that we called equation 3. And then when I times this by 6, we've got 102x minus 30y equals 6. So we did decide that because the terms were different, we would add them. So I'm now going to add equation 3 to equation 4. When I add them, I get, well, let's see what we're adding here. Let's really concentrate on what we're adding, because it's easy to make a mistake. We're going to be adding those terms. We're going to be adding those terms. So when I add 20 and 102, I do get 22x. And when I add 55 and 6, I get 61. And I can get x as the subject by dividing by 122 on both sides. And hopefully you can see that 61 is exactly a half of 122. So this fraction does reduce to a half. Now, what I've done is found half the answer, but I haven't found the y. So I'm going to substitute back into any of my equations will work, because don't forget, these points are the simultaneous solution of the equations. So they should satisfy all of the equations. But if you're sensible, you'll look for the equation with, I guess, the numbers that will be the easiest to work with. And I would definitely say that is equation 1. So what I'm going to do is I'm going to sub x equals a half into 1. And when I do that, I'm going to get 4 lots of x. Well, x is now a half plus 6y equals 11. So a half times 4, well, that's 2. That's fairly easy arithmetic. Then I can minus the 2 onto the other side. So that'll give me 6y equals 9. And dividing by 6 gives me a fraction. And 9 on 6, that is correct, but we always want to make sure we fully reduce our answers. And I can reduce this fraction by dividing the numerator and denominator by 3, which gives me 3 on 2. So I've definitely answered the question now. I found that x equals a half and y equals 3 on 2 would be the simultaneous solution of both these equations. Oops, I don't know why I'm rubbing that out. Let me just write that back in. All right, let's have a look at one more just so you feel happy with how to solve simultaneous equations requiring elimination where you need to change coefficients. So here we've got equation 1, equation 2. If you're super confident, I would pause the video, work this question out, unpause it, and compare your solution with mine. Here it doesn't really matter. We've got quite a few options. I'd probably make them both these numbers 6, or you could make both the y's 6. It really doesn't matter. I'm just going to take equation 1 and times it by 3, and then I'm going to take equation 2 and times it by 2. And I'm just going to begin that process, timesing everything by 3. 28 by 3, that's 84. I'm going to call that equation 3, and then I'm doing equation 2 by 2. So I'm doubling, doubling, doubling. Oops, equation 4. Now I can see that I have two terms that are identical. They are the same. They're not different, they're the same. So if they're the same, we subtract. Now, when I do subtraction, I like to start with the bigger number first, so I will do equation 3 minus equation 4. So we are going to be subtracting here and subtracting here. So 9y minus 4y is 5y, 84 minus 54 is 30, and so I can find y by dividing by 5, and that gives me that y is 6. Now I'm going to take y and I'm going to substitute it back into, and I don't think it really matters with the equations here. You can see the 1 and 2 are pretty similar to deal with. I'm probably just going to put it straight into 1. So we're going to sub y equals 6 into 1. These lines are all required. You don't leave them out. We do explain what we're doing. So we're going to do 2 lots of x plus 3 lots of y. Now y is 6. I'm substituting over here. 3 lots of y equals 28. So 2x plus 18 will give me 28. And I can minus the 18 onto the other side, giving me 2x equals 10 and x equals 5. So there I have it. The simultaneous solution of these equations is y equals 6 and x equals 5. All right, thank you.